nga indi sa bopp wax nga dëgg de xam naa xam naa li nga wax xaar maa ngi lay envoyé benn lien léegi nii nga dugg ci kii bi ci live bi waaw nga dëgg sax fàtte naa sax ñu ngi miit mag yow
Focuses on securing network devices. I have a network set up.
Vidéo kii la quoi cisco la woon en fait live bi vidéo rek la diffusé en fait hein daa arrêté wu xaar kon si seen yi hein
Focuses on securing network devices. I have a network set up, and I have all of my interfaces up. I've got IP addresses configured, and I even have OSPF version 2 routing protocol running between all of my routers, so I can communicate from the 1 network or this 99 network all the way over to the 3 network over here. But I haven't configured any security. No passwords, no encryption, so I need to secure my network devices. I need to secure the management plane where we manage the devices, and I also need to secure the control plane to secure control information like the routing protocol information that's exchanged by OSPF between the routers. So to do this, I'm going to focus first on router R2. Let's start by putting in an enable command. And let's set the clock on the router. Clock set. We'll set the time and the date and the year. Okay, now that I have that set, I can also set this router R2 up as our NTP or Network Time Protocol master. Then the other routers can set their clocks to R2's master time. So what I'll do is I'll say conft NTP master 3. Let's set up some authentication between the NTP server and the clients. NTP authentication key 10. We'll use MD5 encryption and put in a passphrase. NTP key phrase. We'll make it the trusted key. And put an NTP authenticate command. Alright, we have our NTP master server set up. Now all we need to do is go to the other routers and set them up as clients. Before I leave router R2, I also want to set up encrypted authentication between the OSPF routers.
OBS. Waaw xaaral mu partager lien bi sax foofu. Wala ma bàyyi ba madame bi dugg sax su ma jotee message am ma créé mais loolu du ci dara ah.
So to do that, I'm going to set up a keychain. So I'll say keychain, and we'll call this keychain sample 1. It'll be key 1, and the key string will be, this is the key string. The cryptographic algorithm for the key string will use HMAC SHA 256. So we have a keychain sample 1, key 1, the string, this is the key string, and the cryptographic algorithm HMAC SHA 256. Now all I need to do is go into my interfaces. So I'll say interface serial 0/0/1 and do an IP OSPF authentication keychain sample 1. Now when I do this, I'm going to lose my adjacencies to my neighboring routers, so I'll have to put in the same keys on routers R3 and R1 if I want to stay authenticated or keep my OSPF adjacencies. I'll do the same thing on interface serial 0/0/0. You can see here OSPF adjacency change from full, which would be a full adjacency, to down with our neighbor. You can see right now this is at 3.1, so I've lost my OSPF neighbor on R3, and I'm going to lose the neighbor on R1 too. I'll exit out, and I'm done right now with R2. I'm going to focus the rest of the demonstration from router R1. So I'm back in R1, and I've already configured R3 and got OSPF authentication and the NTP to work on R3. So now I'm going to run through it really quickly on R1. So on R1, the first thing we want to do is get OSPF back up and running. So to do that, I'm going to go to global config mode and type keychain sample 1, key 1, key string, this is the key string, CR tab cryptographic algorithm, HMAC-SHA 256, go into my interface serial 0/0/0, do an IP OSPF authentication keychain sample 1. And we got our OSPF adjacency change back. OSPF is working again. Great. So now it's time to get our NTP set up as well. So for NTP, put in NTP authentication dash key 10 MD5 NTP key phrase NTP trusted dash key NTP trusted dash key 10 NTP authenticate, and then NTP server is at 10.1.1.2. The key is key 10. I'll put in a debug NTP all to see if we can get some messages. I did a do debug NTP all, so we should see some NTP debugging associations soon. I did a show NTP associations, and you can see that we've got an association set. It looks like I have an MTP message, so that looks pretty good. I'll do an undebug all. So now that I've set up OSPF routing protocol authentication and network time protocol authentication, it's time to secure the router and put in some usernames and passwords and control the management plane and access to our router. For basic security on the router, I'm going to start with a service password-encryption command, which will put a Type 7 password encryption on all of my passwords, whether it's a line console password, VTY passwords. All passwords will have some level of encryption, even though it's not strong. Then I'll put in the security passwords minimum length to 10. So our passwords are going to have to be at least 10 characters long. Now I'll set up my user account. Username admin01. I'm going to set the algorithm type to script, which uses a SHA-256 encryption, and I'll set the secret password to cisco 12345, which is 10 characters. Notice if I put less, I get an invalid password length. So I'll change that to cisco 12345, and if this was a real scenario, I would not be using such an easy password. Alright, we have a user account now in the router. Now I'll set the enable password. I'll do enable. I'll type ALG tab algorithm type and also set it to script. And the secret will be class 12345. Now that I have that set up, I can go to my line console 0 and set the login to login local so that it accesses the local user database and the user account that I just created. I'm also going to set the exec timeout to 10 minutes so that after 10 minutes, if there's been no activity in the console, it'll log me out. Now that I have that set up, I'd also like to send log messages to my syslog server. It just so happens that I'm running TFTPD32 and I set the settings to enable the syslog server by checking this box right here, and now I have a syslog server. So I have a syslog server at 192.168.99.10. Let's see if we can send our logging messages to my syslog server. So I'll minimize the syslog server and set logging to host 192.168.99.10. I'll set the logging trap level, put a question mark, and you can see the different levels that we can send log messages for. Warnings, notifications, alerts. So I'll set it for severity level 7. So I'll put a 7 in here. And I'll also set the logging source interface to gigabit 0/1 so that logging messages are sent to gigabit 0/1 where my syslog server is located on that LAN. And logging on. I'll go back to the syslog server to see if I'm getting some messages, and you can see I've already gotten a message right here from 192.168.99.1. So that's great. My syslog server is up and running. And now that I have that, I can use some login commands like login on success, send a log message, or login on failures, log every 2 attempts. I can also set a login delay of 3 seconds so that logins have to be 3 seconds apart. The default is 1 second. I'll also do a login block for 180 seconds if there are attempts, three attempts within 60 seconds. So if there's 3 failed attempts within 1 minute, then block shut down login for 3 minutes. Now when that happens, you won't be able to access the router. So what you can do is you can say login quiet mode and allow a certain group of administrators to be able to log into the router when this quiet mode is in effect. In other words, when you can no longer log in for the 180 seconds, we're in quiet mode. And if that's the case, then we'll use an access list so that our admins can actually still access the router. So login quiet mode, access class, permit-admin. Now this permit-admin is the name of my ACL, and I haven't written it yet, but we'll do that next. So to create the access list, IP access dash list, it's going to be a standard ACL named permit-admin. And we're going to permit the 192.168.99.0 network. And we'll have to put in some wildcard bits here. Now that I've done that, let's set up the remote administrative access by setting up the line VTY for SSH connections. Now to do that, what I'll need to do is create a domain name, or set my domain name. So I'll do an IP domain dash name cisco dash academy. I'll zero out any previous keys that I may have had. Crypto key zeroize RSA. It says no signature keys found, so that's fine. And then we'll do crypto key generate RSA keys. There'll be general keys with a modulus of 2048. That should be pretty good. Now that our security keys have been created, SSH 1.99 has been enabled. If we wanted to manually configure it, we could say IP SSH version 2, and there's a few settings that we can put in here too. IP SSH timeout, and we can set the timeout to it times out after 180 seconds. And looks like the max is 120, so I'll set it to 120. As well as IP SSH authentication retries set to 3. Now that we have our crypto keys and IP SSH configured, I'll go to line VTY 0 to 4, set the login to login dash local, login space local, and the transport input to SSH. I can also put an access class and put that access list onto my remote access. Access-class permit admin inbound. A few more commands that are worth doing are setting the secure boot image and using the secure boot image command to create a hidden iOS image file that's basically hidden in the flash memory. In the event of deleting your iOS, there is a backup that is not visible to normal show commands. So I'll use the secure boot image command. You can see here iOS resilience, image resilience active. And I'll save a copy of my running config right now to startup config, copy, run start. save my startup config, and then do a secure boot config command. And I have to do that from global config mode though. Secure boot config to create a secure backup copy of my configuration file that will also be invisible to normal show commands. After that, for security measures, secure many of the open ports that are by default and protocols that are security risk on the router by default. So to do that, there it is, auto. We'll do the auto secure command. And this will auto secure and lock down many of the protocols and ports that are security risks. So we'll say auto secure, and it'll ask me some default questions here. Is this router connected to the internet? I'll hit no. Enter the security banner. So I'll say K, no, unauthorized access allowed. The new enable password, but I'll just put class 12345. And I put in the same password as my enable secret, and it's requesting a different one. So I'll put in Cisco 12345. Okay, so many of the commands here that it's running through have already been set up. Blocking period when login attack is detected. Now that hasn't been set up, so we'll put in a blocking period of 120 seconds. Maximum login failures 3. Failed login attempts 3. Configure SSH server. We already have it set, so we'll say no. And you can see here that it says configuring interface specific auto secure services, disabling the following IP services and all interfaces, IP redirects, IP proxy ARP, unreachables, IP mask replies, all of these will be disabled, which is nice. Configure a CBAC firewall. We can do a firewall later, so I'll say no. And you can see that it's also turned off all of these. The finger service, the pad service, it's turned off CDP for me, made sure the HTTP server is off, source routes, gratuitous ARPs, all of these have been disabled. And you can see no IP proxy ARP, no IP redirects. Many of these things would be the types of things that you'd want to configure in your firewall and have them blocked. And now the auto secure is doing it for me. Apply this configuration to the running config. I'll hit yes. And now I've auto secured the router.